In this series, we will be having problem solving sessions for IIT-JAM exam. This JAM exam is an entrance test for getting admission into IITs for MSc degree, MSc program. So we will look at some of the questions, some of the type of questions and topics which come in such kind of entrance exams. So the first topic in this series that we will look at is simple harmonic motion. Simple harmonic motion. So just a brief history about my educational background. So I did my undergraduate degree, my BSc degree in physics from Miranda House, University of Delhi, and then I wrote this IIT-JAM exam and cleared the exam and gained admission into MSc program in MSc in physics at IIT Kanpur. So I have completed my MSc in physics from IIT Kanpur by clearing this JAM exam. So I would like to share some questions and some tips on how to solve problems which come in such entrance exams. So let us look at one such simple problem to start with. So we will start with some simple problems and then build up the difficulty level. So let us just start by some simple harmonic motion questions. An object oscillates with simple harmonic motion along the x-axis its position varies with time according to the following equation. So this is a very artificial question. So now in this question, we are supposed to determine the amplitude frequency and time period the motion. Part B, calculate the velocity and acceleration of the object at any time t using the results of the second part. Determine the position, velocity, and acceleration of the object at time t equal to 1 second. Determine the maximum speed and maximum acceleration of the object find the displacement of the object between t equal to 0 and t equal to 1 second. So these are the 5 parts to this question. Now this is a very artificial kind of a question, because if you look at this, then 4.0 meters is a very big number. Typically, if you suspend a pendulum in your home or in some laboratory, you would not have such a big amplitude to deal with. So this is, in that sense, a little bit artificial question, but still let us solve this. So the first part says calculate amplitude. Now for simple harmonic motion, we know that the displacement is given as follows. Either sine or cosine function is there. So here A is the amplitude. Now comparing with our given question, we find out that for our question A is 4 meters. Now this is quite a big number this for an amplitude, but if you have heard of the Foucault's pendulum, so you can read more about Foucault's pendulum. Then this has an amplitude of about 6 meters. It is suspended by a very long cable, and this is a pendulum. This is a very long pendulum, which is an experiment used to demonstrate Earth's rotation. So this pendulum indeed has a really big amplitude of about 6 meters. So you can search Foucault's pendulum and then you will come to know more about it. So this is an experiment used to demonstrate Earth's rotation. So we have found the amplitude. This is our amplitude. Then we are supposed to find out the frequency. Now, frequency is omega over 2 pi. Now, in our expression, omega we see is pi radians per second. So, omega is pi radians per second over 2 pi radians. So this is 0.5 second inverse, which is equal to 0.5 hertz. So this is our frequency. Now we need to determine the time period. So time period is nothing but 1 over frequency, which is 1 over 0.5 hertz, which is nothing but 2 seconds. This is the first part to the question. The second part asks us to find out the velocity and acceleration. So velocity by definition is rate of change of displacement. So velocity, if we use this expression for x, this generic expression, then we get the following. Now if we plug in the values given for our question, these values, then we get so this is our velocity as a function of time. Then acceleration is rate of change of velocity. This again, if we use this general expression, and then plugging in the values given for our question, we get the following. So part B is done. Part B says that t is equal to 1.0 second and we need to find out the position, velocity and acceleration. So position at t equal to 1 second is t is equal to 1, so pi into 1 plus pi by 4. this is 4 meter into cosine pi by 4 minus 1, because cos pi plus pi by 4 is equal to minus of cos pi by 4. So this is nothing but minus 4.0 meters, and cos pi by 4 is 1 over root 2. So let us put in the values. 1 over root 2, if we rationalize, multiply and divide this by root 2. So this is approximately root 2 is, we can take 1.414. So this comes out to be roughly minus 2.83 meters. Next, we need to find out the velocity at t equal to 1. So this is at t equal to 1. So velocity at t equal to 1. Times pi sine pi plus pi by 4 Now sine pi plus pi by 4 is minus of sine pi by 4. So this makes it, and sine pi by 4 is 1 over root 2. And this comes out to be approximately 8.89 meters per second. 8.88 meters per second. Then we have acceleration at t equal to 1. Again, cos pi plus pi by 4 is minus cos pi by 4. This is equal to this comes out to be roughly 27.9 meters per second square. So we have found out the velocity and the acceleration. The next part asks us to find out the maximum speed and maximum acceleration. So if you look at the expressions for velocity and acceleration, the maximum would be when sine and cosine take the value 1. So maximum would be this amplitude of velocity and acceleration functions. So that is simply 4 pi meters per second for velocity and 4 pi squared meter per second squared for acceleration. So let us write down the expression that we found for velocity and acceleration first. So this was an acceleration so our maximum speed is going to be so when the sign takes the value -1, then we will get -1. So -1 into -4 pi is +4 pi. If it is +1, then we get -4 pi. So magnitude of that would still be the same, but just the sign is going to be different. So maximum speed would be the magnitude of the maximum velocity. So this is going to be nothing but 4 pi meters per second. And this is roughly 12.6 meters per second. And maximum acceleration similarly, that would be when cosine takes the value +-1. Just the sign would be different in both the cases, but the magnitude of that would be 4 pi squared meter per second squared. And this comes out to be roughly 39.5 meters per second squared. This is maximum speed and maximum acceleration. Now we come to the last part. We need to find out displacement between t equal to 0 and t equal to 1.0 seconds. So let us find out the position at t equal to 0. This is equal to this comes out to be roughly 2.83 meters. Now the position, the displacement at t equal to 1 second is as follows. Now cos pi plus pi by 4 is minus of cos pi by 4. So this is equal to minus, which is approximately minus 2.83 meters. So the displacement will be the final position minus the initial position. So this is So our displacement is minus 5.66 meters. This solves the question.